Okay, Year 9s by request. Here is some revision stuff for your topic for geometry. So let's just go through some things. So here we go. This is about triangles and how let's move that up a bit, how we can figure out what it is. Remember, there's always 180 degrees in any triangle. So what we say is that if we know the other two sides, this is a little bit blurry. If you know what the other two sides are, so they're 40 and 77, then the leftover one must just be 180 minus the other two things. So we know that x is 63, all right? Hopefully that makes sense. You can pause it and rewatch it if you need. Let's do the next one. So the next one is about quadrilaterals. So the first one is, remember that there's always 180 degrees in any triangle. In quadrilaterals, there's always 360 degrees, okay? So if we have something that looks like this, and we're told that there's 85 and 92 and 88, and the other one is 2x. So we know that 2x has got to be 360 minus all the other ones, because remember there's 360 degrees in any quadrilateral. Remember, a quadrilateral is any four-sided shape, okay? So anything at all with four sides. So we end up with 95. Now, because it's 95, that's actually 2x, oops, over here, 2x in the corner over here. So that means 2x is 95. We want to find out what just x is. That means that we need to divide it by 2, because there's 2 of them, right? So if 2x is 95, 1x has got to be 47.5, because it's just got to be half of that. Okay? Hopefully that is helpful. If not, rewind, watch it again. Okay, what else have I got? Oops, let's put that over there so I don't get mucked up. Okay, the next thing we've got to do, this is another quadrilateral one, but this one's slightly trickier. Okay, so there's some algebra involved in this one as well. So if we have all x's, okay, but we still know that the whole thing together must equal 360, because any quadrilateral is 360. So all we do is add everything together, all of those things together, all equal 360. Remember this little square up the top? That's the sign of a right angle. Right angle is always 90. So we add them all together. We say 90 plus 3x. So 3x is over here, and then 2x, and then x. All of them together are 360. And then how many x's do we have all together? Well, we've got 3 x's and 2 x's and another x. So there are 6 x's all together equals 360. Now what we do is move things around like we normally do with algebra to end up with x on its own. So we've taken the 90 here and we've put it over the other side. So it's plus on this side. So we do the opposite on the other side. Remember, if we move anything to the other side of the equal sign, we do the opposite of what it is. So it's a minus on the other side. 360 minus 90 is just 270. And then we want to get rid of the 6 because we want to find out what x is. Now remember, if there's no sign, it means times. So that's really 6 times x. What's the opposite of times? It's divide. So over here we're dividing by 6 because we're getting rid of it from up here. Okay, and then 270 divided by 6 is just 45. Now you can just do that on your calculator. So we can find out what x is equal to, all right? So once again, just do it slowly until you find out what x is. Move everything around till you end up with x by itself. If you're going to move something to the other side of the equal sign, you just do the opposite of what it currently is. Okay, hopefully that made sense. Now let's look at some similar triangles. Remember similar triangles? So up the top I've written similar triangles, big over little equals big over little. That's what we're doing, okay? So we find the sides that match. If they're not lined up, like this one's nicely lined up, but if one of them was flipped sideways or something like that, you might have to line it up yourself. So make sure you know which sides match, okay? Big over little equals big over little, and they've got to be matching sides. So here we've got 4.5 and 2. You see that? 4.5 and 2 are the matching sides, and x and 6 are the matching sides. So we put those together. Then the first thing we do is cross multiply. So we've got 2 times x. So let me try and point to that. So there's a 2 and an x, so we're multiplying those, and the 4.5 and the 6. I'm having trouble pointing backwards. Yeah, so that's what that is, okay? So we cross multiply, so we end up with the next line, 2x equals 4.5 times 6. 4.5 times 6 is 27. And we've got 2x on this side, and we want to get just x. So remember, what do? We do the opposite. It's 2 times x. So we move to the other side, and we divide. And we end up with 13.5, 13.5, okay? So that's how we find out what x is. So remember similar triangles. It's big over little equals big over little, then cross multiply, and then just solve normally with your algebra. Hopefully that makes sense. If not, once again, pause it and watch it again. Whoop, my screensaver just came on. That's confusing. Okay. I also wanted to talk about, oh, actually, before I go into that, how about I just show you this again? A lot of people have been forgetting their angles, so alternate angles corresponding co-interior. If you're forgetting that, just jump on, not jump on your book, don't jump on your book, open up your book and have a look in there again, because that'll explain things. So remember, corresponding angles, they equal the same thing and they look like that. Alternate angles also equal the same thing and they look like that. And co-interior angles are exactly what it sounds like. So they're co-interior, they're in the same space inside the same bit, and they will add up to 180. Okay, see the alternate ones, how they're opposite like that? They can also, hang on, let me just grab a different coloured pen. Where am I going? Here. Okay, so you can also do these ones. Okay, let's just put another dot there. Okay, so see the purple stuff over here? So these two here, they are also the same, okay? So they can also be exactly the same ones. So they're opposite each other, okay? So don't forget about that. Hopefully that will help you. If you can't remember this, jump on this video again and just pause it there so you can look at it, okay? But that's a really good thing to learn. That will help you, not just for this test, but for other things in maths as well. All right, the last thing we'll look at is scale, about, you know, when we're talking about scale drawings, like what architects would use, that type of thing. So here we go. Scale. So we always have the little number on the left side and the big number on the right side, okay? If the scale is 1 to 25, all right, let's do an example with this one. So if a line is 6 centimeters on the page, how big would it be in real life? Well, remember the little one is on the left side, the big one is on the right side. So the left, oh, let's just read that. The left side is the small side, so we need to get the 1 to 6, okay? So to do that, all we do is times it by 6, because 1 times 6 is 6. So because you've done that to the first side, you must do it to the other side as well. So instead of 1 to 25, you end up with 6 to 150. So in real life, it would be 150 centimeters long if it was 6 centimeters on the page, given that scale. All right, I hope that makes sense. So whatever you do to one side, you've got to do to the other side as well, okay? All right, I hope that makes sense. Now, the thing about that one is that one was a little bit easy because it was already in the same unit of measurement. So remember, you have to have both sides of the scale in the same unit of measurement. So if you're going to deal with centimeters, they've got to be both in centimeters. If you had an example like this, so remember scale is all in the same unit of measurement. If it's not, you need to do that first. So if you're given something that looks like this, which is 1 centimeter to 200 meters, you've got to make them both into centimeters first. It's much easier to make them both into the smaller unit of measurement first, okay? So don't try and turn them both into meters, because then you'll end up with decimals. And I mean, you'll get the right answer, but it's just messy. There's no point. So we end up with 1 centimeter to, well, there are 100 centimeters in a meter, so we have to multiply meters by 100 to get down to centimeters. So we end up with 1 centimeter equals 20,000 centimeters. And remember, when we write our scales, we don't want units of measurement in there at all. So we take them away. So it's just 1 to 20,000. So that'll make sense, okay? So even though we've worked it out in centimeters, the unit of measurement no longer matters. Because what we've done is we've gotten rid of it and just said, well, it's 1 to 20,000. So it doesn't really matter what we're using, because as long as we're in the same unit of measurement, it's fine. It could be 1 kilometer to 20,000 kilometers, and that would be fine as well. It's the scale that matters, not the particular unit of measurement, which is why we get rid of the unit of measurement in the first place. Okay, that's all I've got. I hope that's really helpful, Year 9s. If you still have questions, please make sure you come and see me before your test. Yeah, that's about it. I hope that was really helpful, and I will see you later.